Hi, I'm Jeff Noble. In this episode, we're going to talk about C# basic data types. This is the Noble Cause Software Development course. What's going on, everybody? So, before we get started, a couple of housekeeping notes. I have changed the resolution of these videos, and so hopefully all the sync issues with sound not lining up are fixed. Let's see how it goes from here. Another thing is I wanted to thank you for sticking with things. This is episode 1. We're going to be talking about some data types, and it's probably the last, hopefully boring video that is in this series. This is just that background that we need so that we can get into actual code. Let's get through this. We'll keep it nice and short, just like the last one. In the next lesson, we'll get to actual coding, and some of these things that we've learned will all come together. Let's jump right in. Let's talk about data types. Basically, when we write software, we're moving information around. That's pretty much what most applications boil down to. Think about a website. You go to a website, you have to sign up, right? You fill out a form, you put in your name, your password, your login, your email, and all of that information you put in gets stored away when you click the sign up button. And it probably gets put into a database somewhere, and then it'll take you to the login page where you'll put in your credentials and hit login, and it'll go out to the database and do some comparisons and make sure that you are who you say you are based on the login and the password. That type of data moving around is really kind of core to writing software, because that's what we do. We search for things, we store things, we recall things. Even in video games, if you want to write video games, you're storing how much money you have, what level you are, what abilities you've gotten, what your high score is. All of these things boil down to simple information that are stored and retrieved constantly with software. So before we can write code, we have to understand the different types of data that get stored, and then the rest of it should make better sense. The first type of data that we're going to talk about are numbers. The simplest number is a number without decimals. In C#, that's called an int, which is short for integer. Range that an int can store is the number you see on the screen, -2 billion, blah, 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 blah. So if you're tracking numbers, if you're adding things up and you don't think that it'll ever get to more than 2,147,000,000, then an int is fine. And really, it's a common data type, one you'll be using all the time. Most things that we are storing, that we're counting, don't really get that large. The next data type is a long. Long are like ints, but they have the potential to be larger numbers. You can see the number on the screen. I don't even know what number that is, but pretty much if you need to store large numbers, a long is the way to do it, as long as you don't need decimal places. You notice at the end of the example here of the range, I've highlighted that in pink, that you can put a capital L after a number to tell C# this in fact is a long. The only time you really need to do that is if you're storing a number that really could be an int, right? Like the number 10. Well, that's within the range of both an int and a long. So if we wanted to store it as a long, we could put an L after it. And that tells C#, even though this could be an int, I want you to treat it as a long. Next up is numbers with decimal places. We'll start with a float. This is a floating point decimal, and floats can track up to 7 places after the decimal point. Again, because there's more than one type of decimal point data type in C#, we can put a capital F at the end if we want to tell C# treat this as a float. If the number you need to store needs greater precision than 7 decimal places, you can use a double. Doubles are good up to 15 decimal places. It's not very often that you need to do this, but sometimes if you have very critical math, maybe you're doing things with maps with, very long latitude, longitude, or if you're doing some critical science that needs to go out to up to 15 decimal places, you can use the double. Typically, when I use decimal places, I always use the double. I have the option of using up to 15 decimal places. It's not really any more overhead than a float, and it always gives me that option of moving out to that precision if I need it later. Last up is the decimal. We use that for money. Yeah, so decimals are good at rounding money, and they're good at tracking decimal places that deal with actual currencies. So make sure if you're dealing with money, you use a decimal. Let's not go in too deep right now as to how those decimals are treated versus doubles and floats. Let's just say that you're going to want to use the decimal to get the correct monetary values of things. Next up, we're going to talk about letters and digits. So the first data type that we need to deal with letters or digits is the char. Some people call this a char. There is no right and no wrong as far as I know. I call it a char. What is a char? It's short for the word character. One single character to be specific. So in the example, you can see that I have a J and I have an E and I have the number 1. Well, wait a minute. The number 1. How can we have a number 1 as a char, but number 1 is also valid as an int, a long, a double, a float, right? When do I make a 1 a char, and when do I make the number 1 an int? Well, that is the distinction between numbers and digits. So you probably never thought about this before, but a number is something that denotes quantity. Your age is a number. It's how many years you've been alive. When you're going on vacation is a number of months from now or a number of days from now. You're actually counting something. But things like your area code, right? I was from South Florida. They're big with the 305, right? So 305, are there 305 somethings? No, it's just an area code. Your zip code is not 10,000 blah, 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 right? It's just 5 digits. When you're dealing with digits, things like social security numbers, phone numbers, those are just digits. They're not how many of something. So those become a char or a string. If you're storing things that are quantity, then you use the numeric types. If you have more than one character that you want to deal with, then you use a string. It's a bunch of chars. So we did that with our last example when we looked at hello world, and we changed that string value from hello world to hello Jeff. In that case, just putting something in quotes is enough to tell C# that I'm talking about a string. So that's called a string literal, because you're literally putting what you want the value of that string to be inside double quotes. Also, I want to point out that a char is single quotes, which is the shift and the quote key on your keyboard, and on most keyboards, and the string is double quotes. All right, moving on. Next up, we have Booleans, which are simple true, false. Either something is true or it's false, and C# calls that data type a bool, B-O-O-L, and you use that whenever you need to track whether something is true or false. There are things we're going to learn coming up very shortly called if conditions, where we check if something is true, then do something, and if something is false, then we'll do something else. There's really nothing more to bool data types. They're very simple. And that's pretty much all there is to it. So here's a summary of all of those put together. Your numbers, your currencies, your Boolean true or false, single character chars, and multiple character strings. If you can remember those, you're going to have no trouble. That's as complex as it pretty much gets with simple data types. So that's it for this episode. Thanks for joining. Be sure to tune in on the next show when we actually put all of this information to work, and we actually will make our computer do some stuff for us. All right, I look forward to seeing you then. Take care.